Today we're going to look at compound interest. This is similar to the exponential growth models that we looked at yesterday, only there's a piece added in. What's added in today is this value n. Everything else, if you recall from yesterday, was a compound growth looked as this. So we have n, and it occurs twice in our formula. So that's what we're going to look at today, setting up this formula for a given situation. However, we're not going to solve them today. We will deal with that tomorrow. So right now we have to define all the different values. So today we're using the letter P for principal amount, which still represents the initial amount. So in here, Tamara invests $3,500 at 2% compounded annually for 5 years. How much will she have in her account after 5 years? So our principal amount is our initial or starting value, which would be $3,500. The R still stands for rate, and that's going to be 2%. And just as we did yesterday, we need to write that in decimal form. So I'm going to change that. 2 places to the left would put me at 1, 2. So it's going to be 0.02. So the value is 0.02. And then we have to deal with n. And n stands for the number of times the interest is applied over the course of a year. So if it's compounded annually, that means it's once per year. Every year is annually. So n equals 1 in this situation. And then the t stands for the amount of years in all, the length of time. So here is my t, is the 5 years. So now it's a matter of setting it up. So I'm going to set it up as A equals 3,500. The parentheses is going to be 1 plus my rate of 0.02 over n, which is 1, and then n times t. And my last step is to simplify this. So I should have a formula that says A equals 3,500 times 1.02 to the 5th power for this example.